Welcome to A-Level and AP Physics. In today's class, we will discuss past paper questions on electricity and radioactivity from June 2022 paper 2. In this class, we will discuss concepts about these two topics. Means we will talk about electricity and radioactivity. And we will try to improve our understanding of these two topics by solving past paper questions. Let's study together. Let's improve together. For our question number 6, part A1 on figure 6.1, we need to sketch the IV characteristic of a filament lamp. Simply, we need to sketch IV curve for filament lamp. For filament lamp, we need to understand as voltage increase, more electrical energy is converted into thermal energy. As more thermal energy is produced, temperature of filament lamp will rise. As temperature rise, resistance of filament lamp increases. We have to use this concept and we need to sketch the curve. We also need to understand resistance is equal to V over I. If resistance increase with voltage, it simply means that the ratio between V and I also has to increase. Means the ratio between these two quantities also has to increase with voltage. Now let's try to sketch IV curve using these concepts. We have discussed as V increase, resistance increases. It simply means that the gradient of the curve has to decrease with increase in V. So this is how we can sketch, and your curve has to be in first and third quadrant, and it has to be symmetrical in these two quadrants. So we can simply say this is first quadrant and this one is third quadrant. It simply means that, you see, in this case current is negative. It means the polarity of the battery is reversed. So let's try to understand what exactly it means. Let's say this is over power supply and here we have one resistor. So in this case, this side is positive, this side of the battery is positive, so current will flow in this way. So we have this curve, means current is positive. This way we are taking current is positive. So this means that now the polarity is reversed. Now this side is positive, so current will flow in opposite direction. So simply we can sketch here. Now this side is positive, so conventional current will flow this way. Here you can see current is flowing this way. We have taken to the right is positive, and in this case current will flow to the left, and we have taken this one as negative. So that's the reason this curve is in third quadrant. This question has 2 marks. First mark is M mark. You will get this mark if this curve is passing through this origin and this curve is in first and third quadrant. So you will get first mark if this curve is passing through origin and the curve is in first and in third quadrant. You will get 1 mark. That is M mark. And the second mark is answer mark. If this curve is symmetrical, it is symmetrical and gradient is decreasing with increase in V. Means we can simply say gradient is decreasing with increase in V. You will get the second mark. This is how marks will be awarded for this question. In this circuit, this resistor is representing filament lamp, and this resistor is also representing filament lamp. So these are filament lamps. For the second part, we need to explain the shape of the line in A1. Means we need to explain the shape of this curve. For this curve, we need to understand, first of all, as V increases, so I will be writing here, as V increases, it simply means that more electrical energy is converted into thermal energy. More electrical energy converted into thermal energy. As more thermal energy is produced, it means temperature of filament lamp rises. So we can say temperature of bulb, or you can say filament lamp increases. As temperature of filament lamp increases, it simply means that vibrations of ions increases. It means ions vibrate faster. So we can say vibrations of ions increases. As vibrations of ions increases, they make very difficult for electron to flow. Means it becomes difficult for electrons to flow. So simply we can say difficult for electron flow. Electrons cannot flow easily. So difficult for electron flow. As electrons cannot flow easily, it simply means that current decreases. So the rise in current decreases. So better way to say this one is, we will say the rise in current with voltage decreases. So we can say delta I means the rise in current with V decreases. It simply means that the ratio between V and I, this ratio increases, and this ratio is equal to resistance. And that's all what you need to understand to answer this question. And now if you look at the shape of this curve, you can see the gradient of this curve decreases. This is telling us the ratio between V and I increases because R is equal to V over I. So the ratio between these two quantities is increasing. It simply means that R is increasing. R is increasing. So that's all what we need to understand about this question. Let me show you the answer, how you can write down a proper answer. In order to write down answer for this question, you have to mention 3 important points. So let me clean this one so you can see what I have written. So these points you have to mention in your answer. If you have mentioned as current increases, temperature of the filament wire increases. As temperature increases, resistance of filament wire means the resistance of wires of filament lamp increases. As voltage across lamp increases, the graph curves means the gradient decreases. It simply means that the ratio between V and I increases, and ratio between V and I is equal to resistance. So it simply means that resistance increases. If you mention these 3 points, you will get 3 marks, and this question has only 3 marks. For part B, it is given to us a conducting wire has length 5.8 meters and cross-sectional area is equal to 3.4 times 10 to negative 8 meters square. Resistivity of the metal wire is also given. We need to calculate resistance of the wire. So simply, this question is very straightforward one. Simply, you need to understand how to use this equation. Resistance is equal to rho L by A. Now simply you need to plug in values. In this case, value of resistivity is given, that is equal to 5.6 times 10 to negative 8. L is given, that is equal to 5.8 meters, and cross-sectional area is also given, that is 3.4 times 10 to negative 8 meters squared. Now simply you need to put these numbers into your calculator and you can find value of resistance. The resistance in this case is equal to 9.6 ohms. So this is our final answer. So simply we can say resistance is equal to 9.6 ohms. This question has 2 marks. The first mark you will get if you have written this equation, means you have written this formula. You will get 1 mark, and this is C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part C, it is given to us a resistor of resistance capital R is placed in a circuit with a cell of negligible internal resistance, 2 switches S1 and S2, and a second resistor of resistance 2R and 3 ammeters X, Y, and Z. The circuit is shown in figure 6.2. The reading on X is 1.0 amps when switch S1 is open and S2 is closed. We need to complete table 6.1. We can simply write down here first of all case 1. So we will be talking about case 1 first of all. For case 1, it is given to us when S1 is open and S2 is closed, reading on X. So let's sketch our circuit. So this is the circuit now. S2 is closed. So this is what you will see. So this is our circuit now. So this one is our circuit. We can also draw this solid line. So this one is our circuit. If current passing through X means I passing through X, this is equal to 1.0 amps. Then current passing through ammeter Z also has to be equal to 1.0 amps because they are connected in series. So simply we can say current passing through ammeter Z is equal to 1.0. But current passing through ammeter Y, this one has to be equal to 0 because no current will will flow this way because this switch is open. So this is case 1. One thing more we need to understand about this case. If we connect our voltmeter between these 2 points, let's say we connect voltmeter here and we connect voltmeter here. So the reading on this voltmeter has to be equal to the potential difference across terminals of this power supply. We can say the potential difference across terminals of this power supply is equal to V. So the reading on this voltmeter also has to be equal to V, because switch is ideal switch, means there is no voltage loss, and this ammeter also is ideal ammeter, means its resistance is negligible, so there is no voltage drop across this ammeter. So in this case, simply we can say when potential difference is equal to V, current is I, R is the resistance. But in this case, current is equal to 1.0 amps passing through this resistor when resistance is to R. When resistance is to R. So from here we can say I current is equal to 1.0 amps when potential difference is V and resistance is equal to R. So simply we can write down this is our case 1. For the second case, it is given to us S1 is closed, then S2 is open. Means this one S1 is closed, then this one is open. So we can redraw our circuit again. So you can see now this is our circuit now. So this is our circuit. So we can simply redraw. This one is our circuit. In this case, you can see the potential difference across these 2 points, mean potential difference across this resistor. This one is equal to V. So if you connect your voltmeter between these 2 points, or simply if you connect voltmeter across this resistor, reading on this voltmeter will be equal to V. So we can write down here for second case. Case 2, we have potential difference V. We need to find out current. We can simply say this current we can say is I naught. We can write down this is I naught. So this current we can say this is I1 times the resistance. As V is the same, so it simply means that I naught, V is same. V is same. So this V is equal to this V. We can write down I naught times R. It has to be equal to I1. So we can say this is R naught. I1 times R1. In this case, we need to find out value of I1. So we can write down I naught. So this is I naught times R naught divided by R1. Divided by R1. So I naught is equal to 1.0 and R naught, this is equal to 2R. R1 is equal to R. So simply this R we can cancel with this. I1 is equal to 2 times of I naught. So it simply means that I1 is equal to 2 amps. I have written this one in a proper way so you can get good understanding of this point. Otherwise, I can simply say as this resistance is half, V is the same, so current has to be double. So in this case, current passing through X, this one has to be 2.0, and current passing through Y also has to be 2.0, double than current passing through X before. And current passing through Z has to be 0 because there is no current passing through Z ammeter. So this is how you can answer the second case. For third case, it is given to us S1 is closed and S2 is also closed. First of all, let's clean this circuit and redraw. Our circuit is a complete circuit. So this one is a complete circuit now. Means we have here, so this is our circuit, and then we have 2 resistors, they are connected in parallel. So we have 2 resistors, they are connected in parallel. R and 2R, they are connected in parallel. So this is our circuit now. In this case, we will connect our voltmeter again between these 2 points, means between this point and this point. If we connect voltmeter between these 2 points, reading on this voltmeter again will be equal to V. But in this case, we need to understand resistance. We have 2 resistors, they are connected in parallel. So we can find out the total resistance of 2 resistors. We have R and they are connected in parallel. So first of all, you need to multiply, then you need to add these 2 resistors. In this case, we will get this is 2R squared divided by 3R. So this R we can cancel with this. So we got 2 by 3 times R. So this is the resistance, and we can say this is current I2. We need to find out value of I2, means current passing through X. we can find out value of this. So I2 times R2 we can say. So this is R2. Now in this case, I2 times R2, again it has to be equal to I naught times R naught. We need to find out I2, so we can write down this one has to be equal to I naught R naught divided by R2. I naught is equal to 1.0. We have value of I naught that is equal to 1.0 and R naught. So we can say this is R naught. This is equal to 2 times R divided by R2. R2 is equal to 2 by 3 times R. Now we can simplify this. I'll be writing this one here. So in this case, we can say I2, this one will be equal to 2R divided by 2 by 3R. So simply we can say 3 by 2 times R. So here we have 2 by 3R, or simply you can write down 3 by 2R. So this R will be cancelled with this, 2 will be cancelled with this one. So we got I2, this is equal to 3 amps. So value of I2 is equal to 3 amps. So current passing through X, this has to be equal to 3.0 amps. Now we need to find out current passing through R and 2R. So simply you can say potential difference across R and 2R has to be the same. This resistance is half, so current passing through this one has to be double and current passing through this one has to be half. So it means current passing through this one will be 2 amps and current passing through 2R, this one will be equal to 1 amp, because the potential difference across this resistor and this resistor is the same because they are connected in parallel. But current passing through X, this is equal to 3 amps. So this one is 3 amps. Reading on Y means reading on this one will be 2.0 amps and reading on Z, this one will be 1 amp. So this is how you can write down your answer. I hope this is clear to you. If you have any questions, so please leave your question in comments and I will answer as soon as possible. Let me explain to you how marks will be awarded for this question. You will get 1 mark if you have written these 2 values and these 2 values are correct. You will get 1 B mark. And second B mark you will get if you got all these 3 values correct. You will get second B mark. And third B mark you will get if you got all these values correct. And the fourth mark you will get if all these values are correct. Then you will get 4 marks. And this question has total 4 marks. For question number 7, part A, it is given to us fluorine 18 is an isotope that decays to an isotope of oxygen by the emission of beta plus particle. We need to complete this nuclear equation for the decay, including all the particles involved. So first thing we need to understand, this is beta plus decay. So simply you can write on here, this is beta plus. So the charge on beta particle is +1 and mass number is equal to 0. Beta plus particle is antiparticle. So in this case, electron neutrino will be emitted. So this will be electron neutrino because this is antiparticle. So this will be neutrino, not anti-neutrino. So this one will be neutrino because this one is antiparticle. So this one has to be neutrino. So this is electron neutrino. Now we can write down atomic number and mass number for oxygen. So you can see here, this is 1. So atomic number here has to be 8. You can see this is 0. This is 0. So it means the mass number of oxygen isotope has to be 18. So if you write down these 3 points, you will get 3 marks. And these are 3 B marks. I mean, if this is correct, you will get 1 B mark, second B mark, and third B mark. For the second part, it is given to us a quark in the fluorine 18 nucleus changes flavor during the decay. State this change of flavor. If you look at this nuclear equation, in this case, you can see on left side, we have 9 proton, but here we have 8 proton. But the total number of nucleons, mean the total number of neutrons and protons remains same. It simply means that 1 proton decays into neutron, mean proton decays into neutron. And this is true in beta plus decay. If you look at composition of proton, proton has 2 up quarks and 1 down quark. And neutron, this one has one up quark and it has two down quarks. It simply means that in this case, one up quark decays into one down quark. That's all what we need to write down for answer of this question. So in this case, one up quark decays into one down quark. Or simply we can say up quark changes into down quark. And this question has only 1 mark. If you have written this one, you will get 1 mark, and this is B mark. For part B, it is given to us a hadron as a charge of -2e. E is the elementary charge, and we need to state and explain whether the hadron is a meson or a baryon. So we need to state and then we need to explain. First thing we need to understand, hadrons can be classified into meson and into baryons. Mesons consist of one quark and one antiquark. One quark and one antiquark. So this is composition of meson. Baryons consist of 3 quarks or consist of 3 antiquarks. Quarks are 3 antiquarks. But for meson, it has to be 1 quark and 1 antiquark. But baryons can consist of 3 quarks or they consist of 3 antiquarks. If they consist of 3 antiquarks, we call them antibaryons. Now let's try to find out the charge on meson. First of all, meson. Let's say we have a meson that consists of 1 up quark and it consists of 1 down antiquark. So this is composition of meson. So in this case, the charge on up quark is +2/3e and the charge on down quark is -1/3e. But this is anti, so the charge will be 1/3e. So the total charge in this case will be +1e. Now imagine that we have 1 up antiquark and we have 1 down quark. In this case, charge on up antiquark will be -2/3e and charge on down quark is -1/3e. So the total charge will be -1e. Now if we take one, let's say, down quark and one we have strange antiquark. Charge on down quark is -1/3e and the charge on strange quark is also the same as charge on down quark, but strange quark is strange antiquark, so the charge will be 1/3e. So in this case, charge will be equal to 0, means no charge. From here you can see charge on the meson maximum can be +1e and minimum it can be -1e. Now if we talk about baryon, baryon consists of 3 quarks. Let's say it consists of 1 up quark and it consists of 1 charm quark and it consists of another up quark. In this case, the charge on each up and each charm quark is equal to +2/3. And there are 3 quarks, so the charge will be +2e. It is also possible we have all of them, they are antiquarks. So we have up antiquark, we have charm antiquark, and we have another up antiquark. In this case, we will have charge on each quark that will be -2/3e. So if we multiply by 3, our answer will be -2e. It is also possible we have 1 up quark and we have 2 down quark, as in case of neutron. So in this case, charge on this baryon will be equal to +2/3e -1/3e -1/3e. So the total charge in this case will be equal to 0. So you can see in this case, it is possible that a baryon means antibaryon, it has a charge of -2e. So it means the particle in this case is baryon. It is not meson, because the charge on meson cannot be -2e. So this one is baryon. Now let me show you the answer, how you can write down the answer for this question. This is how you can write down the answer. You can explain this one in 2 different ways. One thing you can say the hadron is a baryon and this has 1 B mark. You can explain this one, you can say must be 3 antiquarks as largest negative charge on single antiquark is -2/3e. So you will get 2 marks. This is one way to explain. So I can say this is one way. But the second way to explain is you can say hadron is a baryon and meson can only have a a charge of 0, or it can have a charge of +1e or -1e. So this is second way to explain this answer. So you can also write down your answer based on meson, or you can write down your answer based on baryon. Any explanation is acceptable in this case. This question has 2 marks, 1 mark for the statement and 1 mark for explanation. But you need to understand in this case, this mark is M mark. So you have to explain. You have to explain this one, then you will get 2 marks. If your explanation is wrong, you will get 0 mark. So M mark is for explanation and the answer mark is for writing this is baryon. For the second part, we need to state a possible quark composition for the hadron. We have already discussed hadron is baryon, and the total charge on this baryon is equal to -2e. And this charge is only possible if we have one up antiquark, we have one charm antiquark, and we have one top antiquark. This composition is possible. It is also possible, you can say, baryon consists of 2 up antiquarks and it consists of one charm antiquark. This composition is also possible. We can also write down there is one up antiquark and there are 2 charm antiquarks. This composition is also possible. The charge on one up antiquark is equal to the charge on one charm antiquark, and this is also the same as charge on one top antiquark, and that charge is equal to -2/3e. So all of them, they have the same charge. So these are some possible quark compositions. In this case, we can also write down it is possible this baryon has one charm antiquark and it has 2 top antiquarks. So it has 2 top antiquarks. I'll be writing here up antiquark, and one charm antiquark. Any composition is right. So if you write down any composition here, you will get 1 mark, and this is B mark.